Hello guys, welcome to reference tutorial on Amazon Web Service EC2 F1 instance and its configuration. We are from Logictronics and Digitronics Nepal, so this is just the reference tutorial. So there are the reference guide and separate tutorial series from Xilinx and AWS. However, those tutorials and reference guide are little messy, so you have to go through the individual links and you have to download respective user guides. So we have just sought out all the information available in Xilinx, AWS and third-party website into single reference tutorial. See, so all the tutorial is actually reference from AWS and Xilinx content, so you can also go through respective websites of Xilinx and AWS for learning more on AWS EC2 or AWS and the F1 instance. So basically you already familiar with AWS. So AWS is the web service platform. So they provide the server architecture and they also provide the specific FPGA based F1 instance architecture for their client. So anyone or any client can purchase the or can lease the system on the basis of per hour charge. So basically AWS provides EC2 F1 instance for configuring and performing acceleration of different type of applications like the genome sequencing, video encoding, transcoding and machine learning applications, as well as there are lots of applications which we also talk on. So for utilizing the EC2 F1 instance, there must have the Amazon machine image, which is the file which we are going to develop for targeting F1 instance, and the hardware development kit is the design tool from AWS, and the Vivado design suite also supports some of the features, and SDK from AWS contains all the necessary resources. And let's see about the configuration of AWS F1 instance or specification. So it consists of UltraScale plus Vertex series of FPGA. So the FPGA is BU9P, and there are different configuration of F1 instance. So one is F1.2x large, 1.4x large, 1.16x large. So there are different sizes according to the FPGA card available, CPU available in those respective cards, and the bandwidth, as well as the storage, networking capability and EBS optimize. So these are the parameters which we taken from the AWS website. So basically the main FPGA is Xilinx Vertex UltraScale Plus 16 nanometer BU9P FPGA device in one instance, that is one card. So if you want to run the application on F1.16x large, then it have 8 different FPGA devices. So you can accelerate your application on those at 8 FPGA device or among 8 FPGA device. So basically let's see about how it works. Actually this contents is also taken from the AWS, and basically there is hardware development kit. So we can write up our custom logic in RTL or OpenCL or C++, and for RTL and OpenCL, C++ custom logic or custom algorithm, we have to utilize SDAxle. So SDAxle provides the interface, and we also have to write the processor applications, and finally we build the Amazon FPGA image AFI. So that AFI is like ready to deployable, so it can be deployed, or a similar type of applications can be taken from AWS marketplace, so that can be included in the design and finally implement on F1 instance. So this is the top level design flow or working flow, and how FPGA acceleration works on AWS. So you might have a little bit confusion. Actually, the main worst application which will run on the CPU, while that EC2 F1 also have CPU, so CPU handles the top level applications, and the acceleration part of application is run on the FPGA UltraScale Plus FPGA, that is PODX. So mainly FPGA handles deeply pipeline hardware accelerated operations, and mainly the planning type of operations, and the overall control and management is done by the CPU, so it separates the operations. So let's see about the application of AWS. So AWS is mostly utilized in genome research, genomics, genome sequencing, and this is the biomedical application or biological data sequencing application. And there is financial analytics. So while in the financial market, the each seconds matter very much. So many stock based companies utilize this architecture or take lease from the AWS. Another is real-time video processing, that means transcoding, broadcasting, etc. Another is big data research and analytics, so large number of data can be analyzed with the machine learning application, artificial intelligence, and generate the best results than the CPU architecture, traditional CPU architecture. Another is security, so many security applications and some management solutions can be run on the AWS. So this is the main applications. However, there are lots of applications of F1 instance, and that can be viewed at AWS web page. So let's see about the development tools. We also talk about SDXL is the main tool. SDXL is actually included in the SDX. However, SDK is the tool which is provided by AWS with collaboration of Xilinx. So SDK looks like basically likes the Vivado. So SDXL is one tool and SDK is another tool. However, SDXL is dominant for designing the accelerators in F1 instance. So basically, as we talk about Amazon machine image, so that Amazon machine image is the final file, that is the file which consists of bitstream and the host CPU program, and finally that is utilized for F1 instance, and it can be separated and programmed to CPU to FPGA acceleration cards. So this is the acceleration method which we already talked on. So basically SDXL allows us to write program custom logic in RTL, that is BSDL Verilog. Another is CC++ or OpenCL API. Another is importing RTL kernel. So there are different three methods. So let's talk about major development methods. So first development method we are talking about is development of AFI image. AFI image actually consists of the hardware part of image. Then after we will merge the host CPU image. So first of all, we have to write the kernels or applications which we are going to accelerate, and we have to generate the binary file for FPGA or like the bitstream. Then we can create the AFI. So here we have listed the steps, and first of all I have to write the custom logic in RTL or C++ OpenCL, and we have to compile it to create the binary image, and finally we can create the AFI. So that AFI creating process is actually, while we create the binary file, it is converted and encrypted into the AFI format. AFI can be securely stored at AWS backend service. So for utilizing the AFI or Amazon FPGA image, we have to generate the AWS XCL bin which consists of AFI ID. So that AFI ID is actually runtime utilizable in the FPGA. So with checking the AFI ID, the FPGA runs the main program. So here we have the flowchart, X bin, create AFI, and this AFI actually takes the ID, and finally we can create the AWS cl bin file. So that can be, actually this is the method for securing your designs in the AWS, and this is just part of the FPGA acceleration. And on talking about the host application, we have to first of all write the OpenCL application. Host application can only written in OpenCL and also in C++ with GCC compiler. The base utilization is OpenCL compiler, and while we run the C++, we need to have GCC compiler, and OpenCL API converts that C++ application and communicate with FPGA. So we have to also include the driver settings for integrating or communicating with FPGA, main FPGA core. So it mainly communicate with the FPGA. So this is the application code development section. This is the first step. Second step is executing the Amazon FPGA image. So as the previous design, this AWS XCL bin file will be provided to the host application, and that host application actually checks and provides corresponding image file to corresponding instance, FPGA instance, and it can run on. So after checking the ID, it will give corresponding file to the instance. And here we have the SDXL testing and execution mode. So SDXL can be utilized for CPU emulation, hardware emulation, and hardware execution. So emulation is actually the testing process and debugging process, and hardware execution is final running the kernels on FPGA device. So another is profiling and optimization. So there are some like profiling options, debug and analysis options, checking the rules and some issues, warnings, and finally we can create the image file. And for securing the design, we can create own AFI as we talk, and finally publish our own Amazon machine image. AFI is Amazon FPGA, AWS FPGA image, and AMI is Amazon or AWS machine image. So this AMI is the final file which can be published on the marketplace. So it will reach to lots of users. Actually, AWS marketplace is the like the Play Store of your smartphone or App Store, and so marketplace show up all the available apps to the users who are going to utilize the F1 instance, and we can finally monetize the design. So this is the monetization process. So let's talk about overview of AWS F1 platform and SDXL. So we'll talk about SDXL, which compiles C++ OpenCL application and finally convert it into host CPU application and FPGA part. So there is the design platform environment. So we also talk about AWS F1 platform model and AFI image. So the AFI image, here we have an example of how hardware encoder, that means video encoder, can be designed and implemented on FPGA. So we have to write first the algorithm, and actually this example is also provided at the tutorial session, which is the link provided here, hands-on tutorial on SDXL for AWS. So there is also the developer lab session provided by Xilinx. So you can go to this link and you will get the example design also there. So another is how to run or launch a Linux virtual machine in EC2. So EC2 supports number of type of programs or softwares, like we can also install Ubuntu and Vivado, even you run the VMs like virtual machines and install any type of Linux. So there are no specified papers listed here, and on reference forums you can just go to Amazon AWS forum for EC2 F1, and for reference link you can also go to the getting started guide with SDXL and RTL kernel. So it will show up you the basic steps, developer lab, which we already talked on previous link, and there is also reInvent 2017 developer workshop. So this lab and workshops have similar lab also, and some advancement is done in this section. And for AWS you can just go to aws.amazon.com/ec2/instance type F1, and third party, actually there is a deep dive on Amazon EC2 F1 instance, and they also have tech talk in slides here. So for academic research and resources, you can just go to university program from Xilinx or AWS Educate and Cloud Credit for research purpose. So you can just apply for these options or opportunities. So finally, we also talk about the overview of AWS F1 platform on an SDXL flow. Actually, this is the Xilinx link provided. So we are going to discuss about this link in next video. So you can also visit this link github.com/xilinx/AWS F1 developer labs/blob/master/readme.md. So this link actually consists of all the necessary information and step-by-step tutorial about the how to build from default application and how to build the very basic video encoding application on SDXL and finally run that application on the EC2 F1. So guys, we will meet you in this lab of AWS F1 configuration with SDXL in the next video. Thank you for watching. We'll meet you in next.